Welcome to the Scalable Computing Podcast, joining you from Stanford in the heart of Silicon Valley. In this podcast, we discuss everything about cloud computing, machine learning, and large-scale systems. This season, you'll be joined by world-renowned guests from both industry and academia who have engineered and built some of the largest scalable computing systems in the world. Your host is Dr. Lamia Youseff, a scalable computing leader, one of the early engineers at Google Cloud, and former Microsoft and Facebook technology leader. This podcast is sponsored by Jazz Computing. Sign up for updates and new episodes at jazzcomputing.com/podcast. And without further ado, let me welcome your host, Dr. Lamia Youseff.
Hello, everyone, and welcome to the Scalable Computing Podcast. Thank you for joining us today. It's a pleasure to welcome Joe Beda to the first episode. Joe doesn't need an introduction. He's an influential thought leader in scalable computing. He's the creator of Google Cloud Engine. He's the co-founder of Kubernetes, which is arguably one of the biggest open source technologies in the world. He's currently a principal engineer at VMware, where he's creating even more amazing and influential technologies. I met Joe in 2011 when I joined Google Cloud. Not only is Joe an influential thought leader, but he's also a dedicated engineering manager who invests in his team. Joe and I today chatted about early days of Google Cloud Engine and what does it take to build such a large-scale system. We chatted about Kubernetes and managing the open source software community. He also shared some of the work that he has been recently doing at VMware around the democratization of cluster management software. Stay tuned for the lightning round at the end of our episode, where I asked Joe about the most surprising use of Kubernetes he has seen, as well as the most impressive software system or company that he's following today. Let's welcome Joe. So jumping right away into GCE, Joe, I'm super curious, when you were building GCE, there must have been one or two challenging and unexpected aspects of building such a large-scale system. What were most surprising to you?
Well, I think, building a lot of things like GCE and oftentimes doing a lot of hard stuff, you don't know what you're getting yourself into. So I started out my career at Microsoft working on Internet Explorer, and, I understood how hard it was to build a browser. And then when I came to Google, I talked to some of the folks that were starting up Chrome, and they're like, hey, you want to come join us? I'm like, no, I know how hard that is. I don't want to do it. And so I think doing something like GCE is only possible because you don't know what you're getting yourself into. If I knew all the things that we were going to have to do to get GCE launched, I don't know if I would have ever started. And so I think, GCE was, I think, a good example, at least personally, that, sometimes experience works against you. Because you know how hard something is, and so you actually don't get started with it. And in reality, it's like big things are done with small steps, and so you just have to go ahead and get going. And so I think looking across GCE, we had to essentially invent virtualization technology at Google. I mean, there was no virtualization at large scale at Google. We had to invent virtual networks. There were no virtual networks at Google. Everything was very custom built for Google's point of view, and so we didn't use any sort of overlay networks or virtual networks. We had to create a virtual block device because Google didn't use those. We had to, we stretched the bounds of sort of how Google exposed APIs. We had, I think, the biggest API early on before Google had all the other cloud services. We had to invent the command line agent for all, and the command line client for this. And so it was fascinating to have to sort of do all these things and not knowing what you're getting yourself into. But, building a team, chipping away at it, that's how these things happen.
Absolutely. Is it the same story with Kubernetes then?
Yes and no. I think one of the fascinating things about Kubernetes is that it came at a time where Docker was already something that was, on the up and up and actually, getting a lot of excitement. And so we looked at Docker and we're like, hey, this, has some sort of echoes of some of the stuff that we do internally at Google. And so a lot of Kubernetes was taking the things that were proven out at Google, that we knew how these things worked, reimagining those for folks outside of Google, because, not like Google is not representative of the rest of the world, but we knew that some of the ideas were, and then being able to essentially, fold that stuff into Kubernetes to make it work. Yeah, so Brendan Burns, one of the co-founders of Kubernetes, used to like to say that, everybody's trying to put these puzzle pieces together of what was happening at that time with Docker and orchestration and everything. But because we had the experience with Borg, as we were doing Kubernetes, we sort of had the picture on the front of the puzzle box. And so we knew how a lot of these things fit together. And so that's why I think, some of the early patterns in Kubernetes worked really well, because we knew how this stuff would work. I think, at this point in the cloud native space, as we look across things, like we're kind of off that map. We've put the puzzle pieces together that we understand. I think there may still be a few things to integrate, but we're also, in places where Google hasn't necessarily, solved this thing, or doesn't have, a decade of experience. And so we're now sort of at this point where we're figuring out with everybody else as a community, and it's no longer a single company with all the answers or a single set of experiences guiding things.
I love that, especially the analogy with the puzzle pieces and the puzzle picture and trying to put things together. And speaking,
that's all, Brendan.
yes, I love this analogy. Makes a lot of sense. But speaking of that as well, so Kubernetes versus GCE, how is it different managing an open source project versus managing a team of engineers?
So I think when you're building a product, especially sort of a cloud SaaS product, the primary thing that you're looking at is how do you build this stuff for scale, and how do you make it so that you and a small set of folks can actually serve a large number of customers without not having any sleep, right? While still getting some sleep. And whereas I think the concerns with Kubernetes was really about how do we make this thing be usable and maintainable by a lot of folks in a lot of different environments. So the diversity, like we only deployed compute engine into Google data centers, right? Whereas Kubernetes gets deployed into all these different places. And so some of the design constraints, even from the get-go, were very different because of all the different sort of situations and scenarios and environments that Kubernetes was going to be running. The other interesting thing is that, open source just works different. In a traditional company, you'll have product management. You'll say, here's the target market. Here's what we're going to build. Here's the sort of the list of qualities or features, and we're going to rank those things. And so it's a much more coordinated effort to move this stuff forward. Open source, product management and open source to some degree is an oxymoron, right? There is nobody that you can tell what to do. The best you can do is essentially try and encourage people to invest in certain ways. But at the end of the day, the folks who show up and who are helping to write the project, they get to decide where they put their efforts and what they invest in. And so that fundamentally changes the dynamic towards, the contributors are the ones that are really steering the ship where things go. Now you can have governance and you can have architects and you can have people say, hey, I don't know where the ship's going to go, but it's not going to go there because we're not going to accept that set of patches. And they can guide folks like, well, here's the right way to do that and get where you're going. But at the end of the day, people bring their own energies, their own passion, and that really helps to decide where the project as a whole goes.
Totally. What I hear from you also is that it's much harder to navigate an open source project to a certain destination than it is within a closed source or within a company kind of project or system, especially from a scalability, but the design means everything from the early, basically the principle, including it to design. What are the main design principles that you feel made the huge difference in Kubernetes to direct it into the right direction?
Well, I think first off, when we started Kubernetes, we had a bunch of relatively senior engineers that had in their heads a relatively, aligned idea of where we were going with this stuff. And this was folks from Google, but also early folks from the community coming on board, like our colleagues at Red Hat early on, for instance. And so that really helped us make sure that, like, at least the initial parts of Kubernetes, everybody was really much in sync and heading in the same direction. And that helped us to establish some of the core patterns, how we did things, the sort of distributed sort of architectural nature of it. And a lot of those things, I think it's gone in directions that we didn't necessarily foresee, but I think that some of the sort of original thinking really has stood the test of time through the different iterations and the growth of Kubernetes. As an example, we have every API object in Kubernetes has a certain layout where we have an idea of metadata with labels, and then we have essentially a declarative model with spec and status. You decide, what do I want the system to do? How do I want it to be? And then the system reports back what the current state is and status. And so that's sort of like metadata with a name and labels plus spec plus status has really worked well across a whole bunch of different areas, in Kubernetes as the project has grown. So I think we got some key patterns like that right out the gate that really helped keep everybody aligned and sort of get things off in the right direction.
Absolutely. And it lends itself as well, if I may add, to the scalability of the system, because now everything is contained, abstracted, and interacting predefined interface. What are the current gaps then in the Kubernetes system? Where do you see the community going?
I think, one of the things that we're putting a lot of effort in at VMware is around how do you create and manage clusters at scale. So I think a lot of folks, they're either managing a single cluster and they're using some open source tools to be able to do this, or they may be using something like a cloud provider, something like a GKE or an AKS or an EKS type of offering. And so what we find is there's a bit of a gap in the community because there's either folks who don't have the resources to contribute, or their needs are relatively modest, or it's folks where they consider their sort of management techniques at scale to be part of the secret sauce that make their product. And so a lot of the effort that we're doing around, the part of the project is called Cluster API and sort of cluster lifecycle. A lot of the work that we're doing there is to essentially reuse Kubernetes patterns for managing Kubernetes itself. And so, and the end goal here is to essentially democratize the ability to be able to run a Kubernetes in a production-ready way. We fundamentally believe that if more folks are running more Kubernetes in more places, it'll sort of be a rising tide lifts all boats and really create a much more thriving ecosystem that really benefits everybody. And so that's where we're putting a lot of investment right now to be part of that sort of democratization of being able to manage and run Kubernetes.
I love that, because Kubernetes is one of the most scalable systems. So why not using it to manage itself? That brings me to also my next question, which is, so we started with VMs and then went to containers, went to orchestrators, then microservices and cloud native. What's next? Where do you envision the 5 to 10 years?
Well, I think the first thing to recognize is that, nothing ever really goes away. I mean, last I heard, and I haven't checked recently, the mainframe business was a growing business for IBM. And so I think, a lot of times people will say, oh, well, is it Kubernetes and containers or is it serverless? And I think the right answer is, why not both? These things can layer on top of each other because there are serverless systems running on Kubernetes. Or you may find yourself in a situation where, some serverless system works well for some part of your application, but you need something that is sort of maybe a little bit more raw for other parts of the application. And so, so I think to some degree, the what's next conversation is really about sort of what are other layers that are going to augment this ecosystem versus replace the ecosystem. And so things that I think are exciting are, when we look at sort of the interplay of sort of platform as a service and serverless and essentially the set of sort of cloud services and such. I think the exciting thing is actually moving this away from essentially a closed space to a very open space. When you look at serverless, the value of something like Lambda on AWS is proportional to the square of the number of things that you can glue together. Whether those be events that are actually triggering your function as a service, or whether it's services that you can then rely upon for storing data or doing video transcoding or who knows what else. And so, but when we look at something like EC2, fundamentally, the set of events and services is almost exclusively provided by a single company. And so what excites me is what are the set of protocols that, and sort of systems that we can do that will enable an ecosystem that gives you a similar level of utility around sort of that, like, scaling with the square, of the number of things you have to hook together that isn't tied to a single entity. And so I think when we look at the cloud world, there are these hyperscalers that are, investing so much money in building these platforms that it really, to some degree, it's hugely innovative and it allows people to build on top of it. But if you wanted to build something that integrated with that, the moat there is pretty high. You're never going to be able to build something on Amazon that can integrate with AWS the way that Amazon can. But can we empower an ecosystem perhaps built on top of Kubernetes, or at least second to, sort of works well with the Kubernetes ecosystem, such that ecosystem can be larger than what any one company can do? And that's a really exciting future for me, is to try and sort of break apart these monolithic platforms that we see in the cloud providers into something that really is a multi-vendor, open source friendly ecosystem.
I love that. Again, just playing again on the idea of scalable computing, making it multi-vendor. So coming quickly to the lightning round, are you ready to play?
I'm ready.
The first question, what is the most surprising application of Kubernetes you have seen so far?
Edge. I didn't think, we weren't thinking about edge scenarios with Kubernetes when we created it. And I think it's been fascinating to see how that's been playing out.
Nice. Most impressive startup or OSS, open source software system, that you have seen recently?
I want to give a call out to Envoy. I really like the set of APIs and control systems that's growing up around Envoy. It's not just for something like Istio. It's being used in so many different ways in so many different places.
One lesson that ML ops should learn from DevOps and the Kubernetes days?
I don't know much about ML ops. I would say, it's a matter of breaking down walls. Don't let your job title define what you do. Find ways to create more communication channels would be the lesson from DevOps.
Nice. Future of infra as a service is
commodity. I think our goal here is to get to the point where a lot of the value is being added higher up the stack.
Kubernetes is the most playing system.
Seven-sided. The Kubernetes logo, for those who don't know, has 7 sides, which is a reference to the internal name before we went public, which was 7 of 9. It was a friendlier Borg. So yeah, a lot of trivia there.
Cloud providers are shooting themselves in the foot because?
It's not bad being a cloud provider if you're successful. I think the biggest problem with being a cloud provider is that it's an all or nothing game. And so it's essentially a high risk, high reward business. And I think that, it's in that way, it's a dangerous business to be in from a corporate point of view.
Joe, it was such a pleasure having you today. Thank you.
Thank you so much for having me on.
Sign up for updates and new episodes at jazzcomputing.com/podcast.